Now we will see how the servo motor works. Okay, this is the servo motor, that is SG90. Its servo name is SG90, servo number. Okay, here the servo, it has a three outputs. Okay, here that means three wires. In that, this is the plus 5, the middle one red is the plus 5 volt, and this side, another side, that is some brown color, that is the ground, and this saffron color, and this color, this one, okay, this saffron color, this is the data pin. That means the servo, it is like a usual it is like a motor, but here the advantage is that through this data pin we can control how much angle it has to rotate. That means if we take like this as a 0, then I want my servo to rotate 40°. Okay, then it will rotate only this much, then it will stop, and we can control its speed, how much fast it has to rotate. Everything you can control in the servo motors, but in usual normal motors it will rotate continuously, but here you can make like how much it has to rotate and all those things. Here in this SG90, it is a 180°. That means you can control from 0° to 180°, 180° to 0°. It will not work in the opposite side. You can make it work in the opposite side also, but you need to here inside there is one lock is there, you need to cut that lock, then you can make 360°, or else you can directly buy the 360° servos which is available in the market. This is the 180° servo motor. Okay, now this has the three wires. This is a female connector, but here also female is there, so we need to use some male to male connectors, that means jumper wires. This you can get in the shop, male to male and all. So now I will connect okay, yeah, I will connect these things to my servo. Yeah, I connected. Okay, then here this is the ground, this last pin is the ground one, so this one, my green pin here. Okay, this green pin I will connect it to the ground, say connect it to the yeah, this I connected to the ground. Okay, then the middle one, that is the blue color one, this is the plus 5 volt, so that I will connected that to the plus 5 volt. Okay, here the plus 5 volt is, this is V ground, yeah, this one is the plus 5 volt. Okay, then this one I will connect it to the, what is this pin? This pin is my control pin. Control pin, we need to connect it to the digital pin. Okay, here my digital pin, I will use the 6, pin number 6. Okay, pin number 6 I will use as my digital pin. I connected successfully to the Arduino. Just see the connections. It is a very simple connections. One pin you need to connect it to the ground, and other to the plus VCC, and other control pin, that is the different color one, that is this saffron color one, that you need to connect it to the pin number 6 or 7 or any digital pins. Okay, now in the code, how to write the code means, first of all we need to include one library file for the servo. So at the beginning, that means before you are into the wide setup, you need to write hash include what, servo dot h, but it seems wrong because s should be capital. Servo dot h, this is a library file, you need to include this library file. Okay, we included the library file. That means the Arduino use some of the codes that are already written in this, that are already wrote in this library. The Arduino uses some of the codes from this library. Okay, then what we have to do, we need to tell that the Arduino, that means the servo is connected to the Arduino, that we need to tell to the Arduino. So for that, okay, I will yeah, okay, so for that what I will do means, but if I tell this servo is connected to the Arduino, if I tell directly, then if I have another servo, then how can I tell? So we need to give some name for the servo. That means just consider this servo as a just a newborn baby now. Okay, Then what is the first thing we have to do? We need to give some name for this child. So what I will do means I will give some name, any name. I will give Chintu as a name. Okay, so for here in the code what you have to write means servo, S is capital SERVO, servo, and your servo name. Servo, okay, servo means it is the keyword. In this S should be capital, servo, and your servo name. What is my servo name? I will name my servo as Chintu. Okay, then Chintu. Okay, then just close it. Then what we have to write? I need some what's that? Variables. You can declare variables in a wide loop also. Otherwise, you can declare in the beginning of the setup. That means they are the constant ints. That means throughout the program, if you define anything in this place, that means the throughout the program, if I declare I equal to 0, if I declare int I, that means int I equal to 0, that means throughout the program the scope of the variable is throughout the program. That is the best word. Scope means you cannot use again declare again int I in the wide loop, and you cannot use that if you declare here. Okay, this is the, if we declare here its life is the complete program. If we declare here, its life is only to that specified loop. Okay, so here I will declare, okay, int I. Okay, int I. Then in the wide setup, now I named my child. That means I named my servo as Chintu. Now what I have to do means the Arduino don't know at which pin we attached this servo. So for that we need to write in the wide setup. We have to write Chintu dot attach our pin. Which pin we are attaching? We are attaching to the pin number 6. Chintu dot attach 6. That we have to write in the wide setup. Okay. Then at this point the Arduino comes to know that we are attached a servo which has the name Chintu, and that is attached to the pin number 6. Now our aim is, what we have to do means, this servo is at some degrees. What we have to do means, initially we need to reset this to 0 degree. Then we need to, I think now it is looking properly for you. Okay, initially it is at 0 degree. What we have to do means, we have to make it to rotate like this, and it has to rotate till 180 degree. Then it has to again retraces the back. Okay, for that here I will use the for loop. For I equal to 0, I is less than or equal to 180, comma I plus plus. Because if we do this servo to rotate from 0 degree to 180 degree directly, then it is harm for the servo, because it will its movement is very fast. It's come like this and it will come like this. Because now what we have to do means, we will increment its angle one by one very slowly, tick 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 tick, tick like this, and it has to come to the again it has to trace its path. So for that, for I equal to 0, I is less than or equal to 180, I plus plus, what I have to write means, here Chintu for this servo I am telling for this servo I am telling from the Arduino that Chintu dot write. This is a function. Okay, dot write is a function. Here the syntax is your servo name dot write. Here also you can declare any of your name. Okay, same name you have to use here and you have to use here. Okay, into dot write, and here I will write I. That means at each time it will I will be incremented by 1. So I will write this. That means it will increment 1, increment 1, increment 1 like that. And here I will give delay, delay of 50 milliseconds. Okay, make sure you are putting the comma everywhere at the end of the line. Okay, I made the delay as 50. Okay, now what this has to do means, what this code will do means, it has to rotate this servo from 0 degree to like 180 degree. Let's check whether it will rotate or not. I will verify the code whether it's right or wrong. So if any error is there, it will give. Okay. Yeah, it's done compiling. I will upload to my Arduino. You can see this RX and TX pin. Now it will blink. Yeah, it's blinked. And yeah, you can see from 0 degree it is rotating to the 180 degree slowly. It is like this. From 0 it start rotating. Tick, 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 tick. Yeah, you see again from 0 degree it is rotating. But you see, while returning back, it will suddenly return. That is harm for the servo. Okay. So now what we have to do means, returning also we will do slowly. For that we will copy from here to here, Control C, and now this servo is at 180 degree. So 180 degree. No, for I equal to 180 degree. I is greater than or equal to 0, and I minus minus, exact reverse of this one. This for loop it has to reverse. So now we will see, we will upload this code. Okay, now we will see whether it will move slowly or fast, what it will do. Yeah, it's uploaded. Yeah, now you see my servo is, it is used for this servo you can use for any home applications like closing of your doors, like small door, that and all. You can do some projects for all those things. You can see now, yeah, it is moving like this and it is returning back, so that you can control any angle. So for example, if I want this to only rotate up to 90 degree, then instead of 180 degree I will write here as a 90 degree. Okay, here I will write as a 90 degree. Now you see it will operate only 90 degree. Yeah, it is uploading. Yeah, from 0 it will start. Now you see it will just straight and it will come back. Yeah, see, it will come back. Remember this syntax. First we have to include a library called #include servo.h, and we need to name our servo. Anything name you can give, any name you can give. And here instead of I told no, this is a global variable. Instead of this, what I will do means I will declare here. That is also fine. Okay, I will declare here also, there is no problem. You can see now. Yeah, it is uploading. Yeah, it's uploaded. Yeah, you can see that this code is also fine. And now we will do one small projects by using all these ideas. So what we have to do means, already we learned how to use the IR sensor. That is, if any obstacle is there, that sensor we know. So now what we will do means, we will do some car parking gates. That means when your car comes near your home, this you can implement just in a prototype. Okay, for real things you need different big servo motors, not servo motors. You need a relay and you need to control the gates and all. We need some heavy motors for that. So just for a prototype, what we will do means, if any vehicle comes like this, okay, now for a time being this is my vehicle. Okay, if any vehicle comes like this, the gate has to open. Okay, open for a around how much time, around 2 to 3 seconds it has to open. Then when it pass, it has to close. Like that we need to make. For that what we want, just you only tell now what we have to use. We need to use the IR sensor, that is this IR sensor. Okay, in this IR sensor, as I already told, this is the ground pin, this pin is the ground pin. So I will connect this to the ground. Here I have two grounds. Okay, I will connect this to the ground, and this middle one, that is the output, digital output. Okay, this I will connect it to the pin number 4. Okay, then here I have another one, that is the plus 5 volt. So this one I will connect it to the plus 5 volt, but here plus 5 volt is I already used this, so I can use this V in pin. Otherwise you can use breadboard and you can give the power supply. Okay, V in pin I will use. Okay, now you can see when any obstacle comes, it will detect. The IR is detecting. Okay, now the IR is connected properly. Now servo is also running. So now what we have to do means in the code, I need to declare. Okay, in the white setup after this much, I need to tell the Arduino that we are connected some IR sensor. So digital read. We have to digital read this pin number called, yeah, oh, I connected to the pin number 3. Okay, this is not 4, this is 3, so we will configure for the 3. So what I will do means pin mode 3 comma input. Okay, pin mode 3 comma input. So now here what I will do means, here I will declare another variable int a. Okay, int a, I will declare another variable a equal to, what I have to do, write uh, digital read pin number 3. Okay, digital read pin number 3. Now if the obstacle is there, then it will give 1 as the, here for this digital pin 3 it will give 1. So a equal to digital read 3. Okay, now what I will do means, if a equal to 1, that means if any obstacle is there, then I will make my servo to, here you can see if a equal to 1, this is the previous code that we wrote. Okay, for I equal to less than 90, that is for this much code we used to make the servo to rotate from 0 degree to 180 degree or 90 degrees there. Here this one I will make as 180 degree. Okay, this one I will make as, no, this is the delay, this has to be 15. Okay, 15 or 20, no, it is 50. Okay, you can take anything. Now we will take this as a 15. Okay, 15 delay time, that's enough I think. Okay, now we will take this as a 15 delay time, and here the after these 3 lines, the servo motor open. Okay, that means when any obstacle detected, the servo will open. After the open, we need to wait for delay around 3 seconds. Okay, that means 3000 milliseconds. These are all in millisecond. Then what I have to do, I have to close again. Okay, this I will close again. Okay, if a equal to 1, these things I have to do. Okay, yeah, I will on this, yeah. Okay, these things I have to do if a equal to 1. Else what I have to do, you can add even the else case. Else anything, if vehicle is not there, then no need to do anything, don't simply write else. Okay, if a equal to 1, then only this will do these things. If it is equal to 0, it will not care about this. If it is equal to 1, that means if any obstacles is detected, then it will make the servo to 180 degree. That means it will open the gate, and after 3 seconds it will close the gate. Okay, so for that, here you can even add a serial monitor in order to confirm that its IR sensor and all are working. So what I will do means, here serial dot begin 9600. Okay, next here after this, if a equal to 1, then what I will do means, okay, I think I forgot to close this if loop, if condition. So here I will close. Okay, now you see this is a for loop, this much part is in a for loop, and delay, and again for loop, this much part is in a for loop, and this is one if, that is closed here. You can see this is closed here. Okay, and this is the our main wide loop which is closed. Okay, now if a equal to 1, what I will do means, inside this I will write serial uh, dot println serial dot println vehicle arrived. Vehicle arrived. I will print like this. Now we will check the code whether it's right or wrong. Okay. Yeah, it's compiling. Yeah. Now I uploaded this. Now what I have to do means I have to place this one like yeah, that means gate. Okay, this is my small gate. Okay, this is my small gate. We need to extend this like completely. We need to extend this. Now the code is uploaded. This is, we need to completely extend this, and here we need to even keep the yeah wait uh, yeah, like this. I think we need to keep. Okay, we'll check, and we need to keep this sensor like this. No, uh, this servo, wait for a minute, I will show you something. uh, when you get the new servo, you will get this many different types of what's that plastic pieces. So instead of that one, for gates and all, we use this one. Okay, use this one. We will remove this. We need to tight this by using some screwdrivers, but I am removing directly and putting this. Okay, now what I will do means I will put like this, and I will check in which direction it is opening now. Yeah, like this we need to keep. Okay, like this I have to keep. What I will do means wait for a minute. uh, yeah, I will keep for a time being. I will keep this one. Okay, this is my my setup. Okay, now this has my Arduino, and this is my path. Okay, this is my path. Huh? Yeah, this is my path, and this is my vehicle. So now what I will do means this is my road, and you can see this. I think I hope you can see now. Yeah, okay, this is my vehicle. When my vehicle comes, this IR will this we have to keep here. Okay, the gate we need to keep something after the distance of this IR. So when my vehicle comes, this IR will detect and it will open the gate. You can see, and this vehicle has to pass in the 2 times, then it will close. Like this we can implement it practically. See, if any vehicle comes, yeah, it will open the gate. So no need of keeping all the watchmans and all those things. We can use this technology. Okay, this is what we can interface the servo motor to the Arduino, and we can even connect other sensors like this. I think you are clear with the code. Don't worry, I will share with the code. Just read it once. It's a very easy code. That's it.